Hey everybody, it's Mr. Buro from Staten Island Tech, and today we're going to be taking a look at the fillet command and the chamfer command. These two commands are also modify commands, and they're traditional in the world of like machine shops and product design and quite a few other things. What they basically do is they round off corners or put like a wedge on a corner. So to make that happen, I'm going to show you a couple of different things. First, I will just use ortho to draw a couple of angular corners that are at 90 degrees on purpose. So there's 3 of them right here. Then I will do that again, except this time I'm going to turn ortho off and draw some more corners. Okay, so let's start with the fillet command. The fillet command, as I said, rounds the corner. I'm going to click the command. At first, you can see a few options are set. The radius is set to 0, and the trim mode is on. You're always going to want the trim mode on. Basically, what the trim mode does is it cuts off the excess pieces. Next, it's going to ask me to set a radius. So I'm going to click radius to force that to happen. And then I'm going to specify a radius. I'm going to do it with my mouse just because I want to make sure it looks kind of nice. So I'm going to estimate kind of where I want this trimmed rounded corner to be, like maybe starting from here, and then I'll measure upward to the line for a distance of about 5 1/3. So that is my set radius. I did it with the mouse because I want it to look nice. Next, it says to specify the first object. So if I click on here as my first object, and then I click here, or I hold my mouse over there, you can see it gives me a preview of that rounded corner. Upon clicking it, it's done. What I want you to know is these original lines are here, they have been shortened. This new piece is classified as an arc. So if I click on it, you see it's called an arc now, and these are lines. Also, if I dimension that arc, you'll see that it has the radius that I specified, which happens to be 5 1/3. And I did it with the mouse, remember. Next, I'm going to do the fillet command again, except here, I'm going to set the radius by typing it. I'm going to type a radius of 50, and then I'm going to select the object here, and then try to select here, but see it gives me the cancel sign over by the cursor, and it says fillet radius is too large. So it actually stops me, which is great, because I don't want to do it if that's the case. I'm going to reactivate command, reset the radius to be something more reasonable, like maybe a 2 to get a nice smaller rounded edge, and I'll select those objects. Doesn't matter which order I select them, because fillet just goes by the radius, and it's set. Now let's do these. These are a little bit different. I'm gonna choose the fillet command again. I'll bring my radius back up to a higher number. Let's pick, in this case, I'll pick like 10, and I will select here and here. You see how it does round the corner, but the rounding is much more shallow in this case. That's not an accident. When you fillet something, it doesn't exactly know how the arc is supposed to be, how long the arc is. In this case, the arc is a 90-degree arc, and in this case, the arc is a 90-degree arc, but that's only because the angular distance between the original lines was 90 degrees. The angular distance between these two lines is much, much, much more than 90 degrees here, which is why the arc is much less shallow. You can see it's only this particular portion of a circle, which actually is 50 degrees by accident. Now look at these lines. These lines are separated from each other. You can still use the fillet command on them. I won't change the radius. Let's see if it's big enough. I'm going to click here, then I'll click here, and it does join them. But look, this line needed to be extended, so it'll do that automatically. The line grows to meet the second click. And it looks nice. Even over here with two lines that appear to be pretty tight, I think both of these lines in this case are going to be shortened. And I'll click those. Radius is too large. Let me click them again. This time I'll pick a radius of 5. And let's see what happens. There, fits in perfectly. And it does indeed trim both those lines. So you have a nice rounded corner there. This one had a radius of 5, this is 10, this is 10, and this is 5, and this is 5. I think you get the idea. So that's what filleting does on normal edges. Next, I just want to show you quickly a polyline. So I'm going to draw a polyline using ortho as like a weird spiral. And I'll spiral the polyline inward so it has many vertices. Now, when I choose the fillet command, I'll leave my radius at 5, but I'll use the polyline fillet option, and by clicking that, it will fillet the entire polyline at all vertices with a radius of 5. So it's a quick way to do all of the vertices inside a polyline or an object with multiple pieces, like even a rectangle. A rectangle has 4 vertices associated with it, and if I do a fillet command with that polyline, fillet on, it'll do all 4 of them and make a nice rounded rectangle. So that's fillet. Chamfer is a little bit the same. I'm going to reset all of these using undo. With chamfer, it makes a wedge cut. So right away, I'm looking at the original set of lines again, and this time, the thing I have to set is a distance. So if I click distance, it asks me for distance number 1, or the first chamfer distance. For this, I'll set it to 4. And then for the other chamfer distance, I'll set it to 2, half of that. Now it says select first line. My first line that I'm going to pick is this line. This line will have a distance cut off of it of 4 from this vertex. So measuring from that vertex inward a distance of 4. This line, because it's the second line I'm choosing, will use the second chamfer distance of 2. So when I click here, you can see that the wedge is cut off more on the first line and less on the second line, because on the first line, my chamfer distance was set to 4, and my second line, the chamfer distance was set to 2. So you can see it's got a longer cut inward. And I'll just extend those lines outward to show you what the original was like. You can see where they kind of cross each other. So this part here was the distance of 4, and this part here was a distance of 2. That line for the chamfer is an independent object now. Here's what happens when you set the chamfer distances to be the same. Let's say 4 and 4 for both. It's what you'd expect it to be, a nice balanced cut. And then there's some other things you could do. Like here's a similar set, but now, for instance, I'm going to set the chamfer not by distance only, I'm going to do by angle too. So when I click angle, it asks me again for the length of the first cut. In this case, I will make it 5. So that means if I select this line first, it will cut inward a length of 5. And then when I set the angle from that line, I'll set it to, let's say, 30 degrees. That means it will cut 30 degrees downward. So I'm going to select the line first. So it'll cut 5 spaces in, and then a very, very shallow 30 degrees downward for making that cut. Let's try that again. Now, I'll do the same thing. Angle. And Chamfer length, let's do 5 again. And angle from the first line, let's do more than that. Let's do 70 degrees. You can see it's much, much, much steeper. Okay, so that was a 70-degree downward angle. So that allows you to specify the wedge cut through a distance like that. And the chamfer also occurs very nicely with these things over here. It's a little bit weird, but you can get the idea. If I do distance chamfering with these two lines, I'll set it to just be 2 for both. It'll change the lines accordingly to make them match with a chamfer distance of just a 2 over there. And I'll try that again over here as well. This time I'll set the distance to 4. Okay, so the lines are modified, both of them. One is shortened, one is lengthened, and that has a chamfer distance of 4. So chamfering puts wedges on an edge, and fillet, not fillet, fillet puts a rounded corner on an edge. You see rounded corners on pretty much everything. There's a rounded corner right here on my cell phone. That is both for aesthetics, making it look nice, but it's also protective of it. If I were to drop my cell phone on a surface, that impact, because of the rounded corner, is distributed throughout the surface area of the back of this object. If the corner was sharp, then it would transfer the shock through the surface of the phone, cracking the glass. Same thing if you're walking around in your house and you just happen to bump into a countertop that has a rounded corner, you just kind of walk away without a problem. But if you bump into a countertop with a sharp corner, it could hurt very much and possibly damage your body. So you have to be careful when it comes to designing things to make sure they're both safe and aesthetically pleasing or beautiful. That's what fillet and chamfer are used for in practical terms, and that's how you use them in AutoCAD. Thank you very much.